Imagine looking on the horizon as the sunrise engulfs half the sky. Betelgeuse, one of the brightest stars, is so large that if it replaced our sun, it would engulf the orbits of Mercury and Venus, coming very close to Earth. The star Betelgeuse, known for its variability, can sometimes become as bright as the brightest stars in the sky, reaching a magnitude of almost 0. Located approximately 700 light-years away, Betelgeuse is the closest star to the Sun that will end its life in a supernova explosion. According to deGrasse Tyson, Betelgeuse's variability means its brightness can change over time, sometimes rivaling the brighter stars. It's fascinating to think about its possible explosion and the terrifying experience it might bring. Understanding Betelgeuse's current situation is essential, and comparisons with stars like Rigel and older Betelgeuse, which also have varying brightness levels, help illustrate this point. These variations result from factors like size, temperature, and distance from Earth. Betelgeuse has many names, including Betelgeuse in Belgium, with origins traced back to the Arabic language. The star is a red supergiant located in the constellation Orion, approximately 642.5 light-years from Earth. Data from the Hipparcos astrometric satellite has provided valuable information about its distance, estimated at around 430 light-years. This helps us understand the vastness of the universe and the immense distances between celestial bodies. Betelgeuse's apparent magnitude varies from 0 to 1.6, making it a variable star. It is known as Alpha Orionis, while Rigel is Beta Orionis, following Johann Bayer's publication. Despite its distance, Betelgeuse's brightness remains high due to its size, being around 764 times the radius of the Sun and 165 times its mass. Its surface temperature is only 3,600 Kelvin, cooler than the Sun's 5778 Kelvin. Betelgeuse, about 10 million years old, is significantly younger than the Sun, which is 4.6 billion years old, yet it is a fully developed star. A supernova explosion within a few tens of light-years would have devastating repercussions. Such an explosion produces light equivalent to an entire galaxy. The last supernova observed in our galaxy was in 1864, but in 1987, one erupted in the Large Magellanic Cloud, 169,000 light-years away. Supernova remnants like G292.0 plus 1.8 showcase the aftermath of these explosive events, with a danger zone around a typical supernova extending up to 100 light-years. Betelgeuse has not yet exploded, though it began dimming substantially in late 2019, causing excitement worldwide. This dimming led some to believe a supernova was imminent, but Betelgeuse has since recovered its brightness and is transitioning back to a less active state. The star, easily visible in the evening sky during the first few months of the year, underwent a massive surface mass ejection, SME, in 2019, losing a significant portion of its visible surface. This unprecedented event was unlike the frequent coronal mass ejections, CMEs, on our Sun. Betelgeuse's distance is estimated to be around 724 light-years from Earth, though this is challenging to determine precisely. Despite its distance, it remains one of the brightest stars due to its inherent brilliance, approximately 100,000 times brighter than the Sun. This immense energy quickly depletes its fuel, hastening its end. Eventually, Betelgeuse will run out of fuel, collapse, and explode as a supernova, becoming extremely bright for weeks or months, possibly matching the brightness of the full moon. The dimming of Betelgeuse in late 2019, which saw its apparent magnitude drop from 0.5 to 1.7, puzzled astronomers. However, the star began to restore its brightness early in 2020. Astronomers used the Very Large Telescope, VLT, to study this phenomenon and suggested two explanations. The first involves the star's internal convective cells creating hot and cold areas on its surface. The huge dimming episode was also caused by a cloud of dust that obscured the starlight from our perspective. This cloud was also created by Betelgeuse. It is still unclear exactly when Betelgeuse will erupt. On the other hand, the supernova explosion would be visible on Earth even during the daytime because it is rather close to us in terms of stellar distance. Fortunately, because Earth is more than 500 light-years away, this massive explosion of matter won't have any impact on us. Astrophysicists estimate that for a supernova to have any impact on Earth, it would need to be about 50 light-years away. The red hypergiant VY Canis Majoris displayed excellent dimming episodes in 2021, just like Betelgeuse. The explanation for this, according to NASA's Hubble Space Telescope, was similar to Betelgeuse's fading, but it was just taking place on a far larger scale. Most likely, it won't occur during our lifetimes. However, nobody actually knows when it will blow up. It might occur today or in a million years. Betelgeuse is nearing the end of its life cycle and could blow up at any point in the next 100,000 years. But because it has drastically dimmed during the past few months, it has drawn a lot of attention. Betelgeuse pulsates, and it has done this before. Therefore, it is not unexpected that it has diminished. But this specific fading has turned out to be unique. Betelgeuse is one of the brightest stars in the sky, shining at a magnitude of 0.69 and ranking 11th among the brightest stars. However, most recent estimates indicate that it has diminished to about magnitude 1.7, removing it from the top 21. Betelgeuse has consequently grown unusually dim. Betelgeuse's bizarre fading has been discussed in the media, with theories abounding that it may be a sign that the star is poised to explode as a supernova. Most professional astronomers and astrophysicists, however, do not accept this theory and think that the star will eventually return to normal. Since the current dimming is caused by other sources, such as an explosion of gas or dust or variations in the brightness of the star's surface, therefore, even though Betelgeuse is set to disintegrate eventually, the scientific community agrees it's not anytime soon. Let's assume what would happen if Betelgeuse eventually popped. What would we see and feel from here on Earth? In the years 1006, 1054, and 1857, the three brightest supernovae ever seen in our skies first appeared. Each of these stars was either as brilliant as Venus at its brightest or was on par with it. They were all, however, thousands of light-years apart. Betelgeuse, however, is just 640 light-years distant. This means that if the star were to explode suddenly, it would become extremely bright, maybe approaching the brightness of the full moon, and produce distinct shadows even in the brightness of the daytime sky. It would be easily apparent. In the following years, where we once saw Betelgeuse, we might only see a diffused patch of faint light. That would be the intensely hot newly revealed core of the star, surrounded by an expanding cloud of gaseous debris. It would initially appear at this dazzling brightness for 2 or 3 months. Then, over the course of the following 2 or 3 years, it would gradually fade from view. If there were no other repercussions on our planet, that would be the extent of the explosion. Overall, Betelgeuse is lucky to be where it is in relation to us and not closer. For example, Capella, a very bright yellowish star that crosses high overhead in the middle of the evening. The distance is only 43 light-years. Arabic is the language that gave rise to the naming of many prominent stars. This fact is illustrative of the preeminent position held by Arabic astronomers and astrologers during Europe's Dark Ages. The term Betelgeuse comes from an Arabic phrase that is typically rendered in English as the armpit of the giant. Some scholars believe that Betelgeuse is meant to be seen as a hand or even a shoulder at times, in contrast to the common interpretation that the giant relates to Orion. Betelgeuse is the name of the star that appears on the right shoulder of Orion on many older star maps. The meaning of the name is not totally understood. It is not unexpected that the majority of portrayals of Betelgeuse have an anatomical relationship because Orion is most commonly associated with a giant, a warrior, a hunter, a god, or some other anthropomorphic or animal figure in the ancient stories. Even though it was most likely the leg of a stag, the Sanskrit term for this structure also referred to it as an arm. For instance, in some regions of Brazil, the constellation Betelgeuse was seen as the front leg of a turtle or the back leg of a caiman, a species of crocodile. Betelgeuse, on the other hand, was thought to be an integral component of the circumference of the rim of a ceremonial drum. In ancient Japan, Betelgeuse represents an amputated limb of a man figure. In the Americas, the Talip of Brazil refers to the constellation as Zil Kawai, a hero whose leg was amputated by his wife. With the varied brightness of Betelgeuse associated with the amputation, the Loda people of North America saw it similarly as a chief with a severed arm. Betelgeuse is referred to as the Moist One in Sanskrit, which is also the name of Hindu astrology Ardra Nakshatra, ruled by the star. The star was ruled by the Vedic storm god Rudra, whose association with Orion's stormy temperament was made by 19th-century astronomy enthusiast Richard Hinckley Allen. In Macedonian tradition, constellations symbolize domesticated animals in farmland, representing the manner of life in the villages. Betelgeuse, along with the remainder of Orion, which showed a plow drawn by oxen, was known to them as Orak, the plowman. In the late summer and early fall, the rising of Betelgeuse at about 3 o'clock in the morning signaled the time for village men to proceed to the fields and plow. For the Inuit, the beginning of spring and the lengthening days in late February and early March were signaled by Betelgeuse and Bellatrix rising high in the southern sky after sunset. These stars held special significance for the Inuit, marking the transition from the long, harsh winter to the more hospitable days of spring. The sight of these stars heralded the return of extended daylight, bringing a sense of hope and renewal to the Inuit people after months of enduring the Arctic darkness. People from North Baffin Island and the Melville Peninsula, in particular, referred to Betelgeuse and Bellatrix as those two placed far apart, or simply those two placed. This terminology reflects the distinctive visual relationship between the stars as seen from their vantage point, emphasizing their separation in the night sky. This separation was not just a matter of astronomical observation but also held cultural and practical significance. The reliable appearance of these stars provided a celestial calendar that guided the timing of important activities such as hunting and fishing, which were crucial for their survival. Ancient societies all around the world took note of the opposing positions of Orion and Scorpius, as well as the bright red variable stars Betelgeuse and Antares that correlate to them. These celestial observations were more than just stargazing. They were deeply woven into the fabric of various cultures and mythologies. For instance, the Inuit were not alone in their celestial traditions. Across the globe, in the southern hemisphere, the Mai of New Zealand had their own interpretations of the stars. They associated Betelgeuse with the star Rua, a symbol of abundance and healing, and its appearance in the sky was linked to seasonal changes and agricultural cycles. In the mythology of the Greeks, Orion was a mighty hunter, and Betelgeuse marked his shoulder, a position of strength and prominence. Antares, on the other hand, was often associated with the heart of the scorpion in the constellation Scorpius. According to Greek mythology, Orion and the scorpion were placed on opposite sides of the sky by the gods so they would never meet. This celestial arrangement symbolized the perpetual chase and conflict, reflecting themes of opposition and balance that were common in ancient Greek thought. The Egyptians also held these stars in high regard. Orion was associated with Osiris, the god of the afterlife, while Antares represented Isis, the goddess Isis's wife and sister. Their heliacal rising, their first appearance in the dawn sky after being hidden by the sun's glare, was used to predict the flooding of the Nile, which was crucial for agriculture. This period of the year was celebrated with festivals and rituals, marking a time of fertility and renewal. In Chinese astronomy, Betelgeuse and Antares were part of a larger system of celestial mapping that included 28 lunar mansions or xiu. Betelgeuse was part of the mansion known as Shun, which represented an archer and was associated with late autumn. Antares was in the mansion known as Zhun, symbolizing the heart of the dragon. These constellations were not just markers of time but were also imbued with astrological significance, influencing everything from agricultural practices to the interpretation of omens. In Mesoamerica, the Maya civilization was known for its advanced astronomical knowledge. They used the stars, including Betelgeuse and Antares, to develop their intricate calendar system. The position of these stars helped them in planning agricultural activities and in conducting religious ceremonies. Their alignment was considered crucial for maintaining cosmic order and ensuring the favor of the gods. Similarly, in ancient Mesopotamia, the Sumerians and later the Babylonians observed these stars meticulously. They believed that the movement of the stars was a way the gods communicated with them, and the positions of Betelgeuse and Antares were used in their complex system of omens. These observations were recorded on clay tablets, forming one of the earliest forms of astronomical record-keeping. These celestial bodies also found their way into indigenous Australian cultures. Aboriginal Australians have rich astronomical traditions, and constellations like Orion and Scorpius are seen in various forms across different tribes. For some, Orion represents the celestial canoe, and its rising and setting times are linked to the seasons and natural events, such as the arrival of certain foods or the breeding cycles of animals. In modern times, these ancient observations continue to be relevant. Astronomy has evolved significantly, but the fundamental human connection to the stars remains unchanged. Betelgeuse, with its variable brightness, continues to intrigue astronomers. Its recent dimming has sparked interest and speculation about its future, reminding us that while we have advanced in our scientific understanding, the stars still hold mysteries. Betelgeuse, with its deep red hue, remains a favorite object of study for both amateur and professional astronomers. Its position as the heart of Orion and Scorpius continues to inspire stories and research, bridging the gap between ancient mythology and modern science. Betelgeuse and Antares, along with the constellations of Orion and Scorpius, have played significant roles in various cultures throughout history, from the Innu of the Arctic to the Mai of New Zealand. These stars have been vital for navigation, agriculture, and cultural rituals. They serve as a testament to humanity's enduring fascination with the cosmos and our quest to understand our place within it. Orion setting and Scorpius rising represent Orion's demise at the hands of the Scorpion. They stand for the opposing brothers Shin and Shang in Chinese culture. The first new moon following Orion's belt's descent below the horizon, while Betelgeuse was still high, like the tail of a rooster, was observed by the Bedouin of Sumatra as the start of the new year. Betelgeuse and Antares placements at either end of the celestial sphere were thought to be significant, and their constellations were interpreted as a pair of scorpions. Scorpion days were designated as days with visibility for both constellations.